Okay, from the previous video, we did the expansion. We did the greatest coefficient of this one. Now we want to do the greatest term. And this time x is equal to 2. So we go back to our expression we had. So if you're not sure, check the greatest coefficients questions video and look at question 3 there, because it deals with this one. And you notice that this time we just got the 3x. That's the only term that had the 5 on 3 before, but now because it's got the x there, the x stays with the 3. And when x is equal to 2, we substitute the 2 in for x. So it gives us a 6r there. And again, we're going to find where it's going to give us the greatest term when x is equal to 2. So the ratio of where is it greater than 1? So we expand our brackets and collect the terms. So we get 11r less than 50, or r is less than 4 and 6 elevenths, which means r would be 4. So 9c4, 3 times x, and x is 2 to the power of 5, times 5 to the power of 4, gives us our greatest term in that expansion when x is equal to 2, so which is pretty large, 612,360,000. Okay, so again, following that process, using what we had before, like I didn't recreate the wheel, I just did was keep the x with the 3, and we're able to go through. 2 plus x to the power of 15, we want to find the greatest term when x is equal to 5 in this expansion. So again, you'd set up your expansion that way. Again, x stays in this time, and when we simplify that part, we get x outside of 16 minus r over 2r. Throw the value of x in there, so that's where it's 5 outside of 16 minus 2r. So, and then we expand that, multiply by the 2r. So in this case, we get I've got 80 minus 7r. It should actually be 80 greater than 7r. So r divided by 7, we get r is less than 11 and 3/7, which means r would be 11. So the 12th term then would be 15c, 11, 2 to the power of 4, and x is 5, so normally be x to the power of 11, but it's 5 to the power of 11. Leave our answer in scientific notation because it's pretty huge. Okay, but again, set up our question like that. When it's greatest term, we leave the x in, get our expression, substitute the value of x in, and then start getting the value of r to get our greatest term.